In today's world, we encounter more airborne contaminants than ever before. That's why in the United States alone, more than 5 million workers wear respirators on the job. Still, over 66,000 U.S. workers suffer severe exposure to airborne contaminants each year, which can lead to blindness, lung damage, cancer, asbestosis, and other serious illnesses. Because of the severity of these problems, the Occupational Safety and Health Administration, OSHA, has created a regulation to protect workers from respiratory hazards. The regulation can be found in 29 CFR 1910.134. One of the things the regulation stresses is learning about respiratory hazards. They fall into three major groupings: dust, mist, and fumes, gases and vapors, and oxygen deficiency and temperature extremes. Dust, mist, and fumes are tiny particles that were once parts of a larger mass. Later, they were separated from their parent substances and became airborne. Dust is produced when solid objects are broken down into fine particles. You can see this in woodworking, crushing, and grinding processes. Mist is made up of droplets that are suspended in the air. They are created when pressurized liquids are sprayed. Fumes are composed of solid particles that are formed when metals or plastics are heated, as in welding and furnace operations. Unlike dust, mist, and fumes, gases and vapors do not result from materials being fragmented. Instead, they are created by changes in the material that take place on the molecular level. For example, gases occur when a substance is heated beyond a certain point. As a result, the space between its molecules increases, and its density sharply decreases. At the same time, it expands, becoming diffused through the air. The molecules forming the gas are not separate from the material. The gas is still the same substance, but in a different state. Materials can also exist in more than one state at the same time. For instance, a liquid can be heated to the point where only part of it is gaseous. When this happens, the gaseous part is often referred to as a vapor. Both gases and vapors can cause immediate irritation when they are inhaled. The final group of respiratory hazards includes oxygen deficiency and temperature extremes. Oxygen deficiency occurs most often in confined spaces through chemical reactions or fire, or from gases that push breathable oxygen out of the area. A lack of oxygen can cause unconsciousness or even death in a matter of minutes. Temperature extremes can also be dangerous. Hot air can burn your airway, preventing oxygen from being absorbed by your lungs. Severe cold can freeze your respiratory tract and make it impossible to breathe. To protect you from these hazards, your body uses its natural defenses. During normal breathing, fresh air is drawn in through the nose, where coarse hairs trap any large particles that have become airborne. Next, the air comes in contact with a blanket of mucus and cilia. Cilia are tiny hairs which line the respiratory tract. The mucus and cilia push the smaller particles to the back of the throat, where they are swallowed or expelled by coughing. Your respiratory system is an effective defense against normal hazards such as house dust and pollen. But more dangerous substances, like poisonous gases and vapors, can sometimes sneak by this defense system, potentially damaging your internal organs or even your brain. When you work around respiratory hazards, you need to be combat ready. This means being aware of potential problems,
Take a look at them.
reading the applicable material safety data sheets and container labels, and following all safety procedures. To begin the process, your safety department will run various tests on your work environment to determine whether respiratory hazards exist. If necessary, they will install air processing systems to purify the atmosphere and set up emergency respirator stations. Other engineering controls, such as lab hoods, can also keep the air you breathe clean. Environmental controls can reduce airborne contaminants too. For instance, spraying water on dusty surfaces will limit the amount of particulates that float into the air. But even with systems like these in place, you may still encounter situations where more protection is needed. These conditions require you to wear respirators. If you suffer from a heart condition or asthma, you should not work in areas where respirators are required unless you have medical clearance. The respirator you use must be right for the job you do. Depending on your type of work, you will use a respirator that filters the air you breathe, purifies the air through chemical means, or provides its own source of breathable air. OSHA's Assigned Protection Factors, APFs, will help your employer determine what respirator should be used in your work environment. APFs indicate how much protection various types of respirators provide. In most situations, an air filtering respirator is what will be called for. Because oil aerosols can sneak through certain types of filtering systems, NIOSH has created 3 filter classifications based on the amount of oil aerosols present on the work site. If there are oil aerosols present, you must use a filter that is coded P for oil-proof or R for oil-resistant. If no oil aerosols are present, you can use an N-coded filter for not oil-proof. When using any filter, make sure that you follow all of the manufacturer's recommendations. Pay special attention to the suggested time use limits. Once your employer has determined whether you should use an N, R, or P series filter, you will need to make sure that the filter you select is also strong enough to block the airborne hazards you are working around. The strength of a filter, also referred to as its efficiency, is listed in percentages, such as 95, 99, and 99.7%, which is referred to as 100%. These are printed on the filter labels immediately following the N, R, and P designations. The higher the number, the greater the efficiency of the filter. It is more difficult to breathe through higher rated filters, so don't use a higher rating than you need. Talk to your supervisor to see which efficiency will best protect you at your work site. For easy identification, OSHA requires that all filters and cartridges be color-coded, with approved labels that display the NIOSH ratings. A cartridge respirator is not usually needed in areas where low levels of dust are the primary respiratory problem. Here, a disposable mask can be used. Fibers in these masks trap and hold particles. To get a proper fit, adjust the metal strip to conform with the bridge of your nose. Make sure the straps are not tangled and that they are placed correctly around your head, one below your ears, the other above them. This creates an even tension on the mask and provides the best seal. When your mask becomes clogged with dust, throw it away and get a new one. However, where more protection is required, you will need to use an air purifying respirator. These have disposable cartridge filters that capture gases and vapors through chemical means before they are breathed in. Remember, before using any air purifying respirator, check with your supervisor to see whether you need a P, R, or N series filter. Wherever there is a high amount of dust or other particulates in the air, you may want to attach a pre-filter to your respirator. This can keep your cartridge filter from becoming clogged by catching the particles before they reach the filter. You can get even more protection by using a full face mask respirator, which will guard against hazards that could irritate your eyes and skin. Sometimes air purifying respirators don't offer enough protection. In these situations, you need an independent source of breathable air. Supplied air respirators, SARs, are attached to a compressor that provides air through a hose. SARs are used where hazardous substances are highly concentrated or there isn't enough oxygen. Another respirator that provides its own air is the self-contained breathing apparatus, SCBA. SCBAs allow greater mobility than SARs since the air supply is carried in a tank on your back. An SCBA's breathing air usually lasts for 30 to 60 minutes, although newer designs allow for significantly longer periods. How long your tank will last also depends on your weight and the stress that your job puts on your body. Before you put on an SCBA, make sure the tank is fully charged. Always check your air supply gauges. Working with SCBAs and SARs can be stressful. When using them, watch for problems that may affect you and your coworkers. For instance, it can be easy for someone who is wearing heavy equipment to tire quickly or be overwhelmed by heat exhaustion. If you wear an SCBA to fight fires, you must follow special procedures set up by OSHA. OSHA requires that at least 2 firefighters enter a burn area and that they remain in visual or voice contact with each other at all times. At least 2 responders must also be stationed outside the danger zone. Whatever type of respirator you wear, check all of its parts before putting it on. Look for wear or damage. Inspect for holes. Make certain all connections are tight. Examine the straps and the seal of the facepiece. At least twice a year, you should also have your safety department check you for a proper fit, because even a tiny gap can let in hazardous gases and vapors. Whether your job requires you to wear SCBAs, cartridge respirators, or dust masks, OSHA mandates that your employer create a written respiratory plan that outlines the respiratory requirements of the jobs at your work site. The plan has to be readily accessible to you and your coworkers. Your employer will periodically review the plan to ensure that it is up to date with current regulations. OSHA also requires your employer to arrange a medical evaluation for you before you wear a respirator. This evaluation will be conducted by a licensed healthcare professional and will determine whether you can safely use a respirator.
Try this one on you.
When you select a respirator, pick one that conforms to your face. Your employer will have at least 3 different sizes to choose from. Make sure that the mask is comfortable. Your employer will show you how to correctly position and adjust the mask for an effective seal. The strap should not have to be pulled uncomfortably tight to keep the mask in place. The mask does need to fit snugly, however, since the seal blocks contaminants from reaching your respiratory system. There must be no gaps between the respirator and your face. Standing in front of a mirror is a good way to check for openings. Even after fitting and testing, your respirator may still feel bulky and awkward. Getting used to wearing one takes time. If you practice wearing your respirator at least 5 minutes a day, you will soon be comfortable with it. When you wear your respirator, make sure that you can be understood when you speak. Test this by reading something aloud to your supervisor. When you're in a hazardous environment, never remove your mask in order to talk. This could be fatal. OSHA also requires all employees to undergo a formal fit test before they wear a respirator. Fit testing ensures that the respirator really does fit tightly against your face. There are 2 types of fit testing, qualitative and quantitative. Qualitative testing uses scented chemicals or smoke sprayed in the air. If you can't smell them, you probably have a good fit. The problem with qualitative testing is that it is subjective, since it relies on each person's sense of smell. Quantitative testing is much more accurate. This uses a machine to measure the exact amount of material that makes its way into your respirator. Even after the qualitative and quantitative fit tests have been performed, you should still test your respirator's seal each time you wear it. This can be done by performing a user seal check, which uses both positive and negative pressure to test how well the respirator seals to your face. To check the seal using positive pressure, place the palm of your hand over the exhalation valve of the respirator, then gently breathe out. If you feel a buildup of pressure beneath the mask and see the sides of the facepiece bulge out slightly, you have a good seal. To check the seal using negative pressure, place both hands over the inhalation valves and breathe in gently. The facepiece should collapse slightly against your nose. Hold your breath for 10 seconds. If the mask stays collapsed, you have a good seal. You must perform user seal checks every time you wear your respirator to ensure that nothing has happened to change the way it seals to your face. There are several problems that could affect the seal, including damage to parts of the respirator, such as the facepiece. Changes to your face can also affect how your respirator fits. For instance, facial hair, including long sideburns, can interfere with a mask's ability to form a tight seal. Dentures, scars, and other physical impairments on the face can affect facepiece seals as well. Eyeglasses can also affect respirator seals. If you wear glasses and use a full face mask respirator, you will need to install a NIOSH-approved eyeglass modification kit. After installing the kit, you must fit test the respirator again. Be sure to talk to your supervisor or your medical department if you wear eyeglasses and need to use a full face mask respirator. Your safety depends on it. Proper care of your respirator is essential. Following recommended cleaning and disinfecting procedures will keep your respirator and you in good working condition. The OSHA-approved cleaning procedure begins with removing all filters, cartridges, and canisters. Next, remove the straps. If your respirator uses hoses, check them for defects. This goes for the valve assemblies too. If you find any defective pieces, repair or replace them immediately. Wash all parts of the respirator in warm water using a detergent recommended by the manufacturer. If you need to remove dirt, use a stiff bristle brush. Never use a wire brush, however. It could seriously damage the respirator. Once you have washed everything, thoroughly rinse all of the parts with warm running water. When the dirt is gone, don't forget to rinse away all of the detergent. Detergent residue can dry and crack rubber and corrode metal. Hand dry the pieces with a lint-free cloth, reassemble the respirator, and test it. Respirators worn by only one person should be cleaned on an as-needed basis. Respirators used by 2 or more people should be cleaned and disinfected after each use. Respirators that are used for emergencies should also be cleaned and disinfected after each use, as should respirators used for training purposes. There are hazardous substances like lead and asbestos that require extra cleanup procedures. Consult your supervisor if you are working with these materials. When you are through cleaning your respirator, put it in its case and store it in a clean, dry place so it's ready to go the next time you use it. Respiratory hazards exist all around us, so do your part to combat them. Be aware of respiratory problems in your workplace. Read material safety data sheets and be on the lookout for other indications of respiratory hazards. Use ventilation equipment and other environmental controls to reduce airborne contaminants. Wear respirators when necessary, and make sure you follow the OSHA and NIOSH regulations regarding selection and use of filters. Before you use a respirator, get fit tested. And use recommended cleaning and disinfecting practices to keep your equipment in working order. When it comes to respiratory safety, always use the right tool for the job to make sure you're breathing safe, clean air every day.